February 1st through the 5th, we're looking at lesson 24, applications of systems of equations and inequalities. Alright, we're just going to look at this. This is something we've been talking about. Our goal for today is to be able to use systems of equations or inequalities to solve contextual problems and interpret those solutions within that text. Alright, so let's go ahead and look at the opening exercise. The opening exercise says this: in Lewis Carroll's Through the Looking Glass, Tweedledum says, the sum of your weight and twice mine is 361 pounds. But Tweedledee replies, the sum of your weight and twice mine is 362 pounds. Find both of their weights. Alright, so with a system of equations, you guys know that we have two variables. Your variables can be whatever you'd like it to be. For this lesson, we're going to stick with the two that we normally see, and that's x and y. So we're going to let x equal the number of pounds Tweedledee weighs, and we're going to let y equal the number of pounds that Tweedledum weighs. Alright, so I have identified both of my variables. Alright, so now we need to take and set up an equation. Okay, so let's look at the first statement. So you have to be really careful how you're reading this. Make sure you understand who is saying it. So Tweedledum says to Tweedledee, the sum of your weight and twice mine is 361 pounds. Okay, so the sum of your weight, so if Tweedledum is saying that to Tweedledee, so the sum of your weight, sum means to add, so we've got Tweedledee's weight plus twice mine, twice Tweedledum's, 2y, is 361 pounds. Tweedledee replies, the sum of your weight, so the sum of Tweedledum's weight, and twice mine is equal to 362 pounds. Okay? So now we can figure this out a couple of different ways. You can figure out what x is, or you can figure out what y is. It does not matter. So if I figure out what y is, if I subtract 2x from both sides, I get y is equal to negative 2x plus 362. So I can now substitute that in to my equation. So x plus 2 times negative 2x plus 362 is equal to 361. And now let's solve it. So x minus 4x plus, we need to multiply that, so that would be what, 724 is equal to 361. Combine my like terms, I get negative 3x is equal to, if I take 724 over, if I subtract that, I get negative 363. Divide by negative 3, x is equal to 121. So I know that Tweedledee weighs 121 pounds because he's X. Now how do I figure out what Tweedledum weighs? Plug this back into my equation. So 121 plus 2y is equal to 361. Subtract 121. I get 2y is equal to 240. Divide by 2. And y is equal to 120. So Tweedledum weighs 120 pounds. And we have used a system of equations to figure out how much they weigh. Could we have solved the problem using only Tweedledum's sentence? Okay, so if Tweedledum says the sum of your weight and twice mine is 361 pounds. Could we have figured it out just with that sentence? Hopefully you said no, because there are two unknowns. We don't know what either one of them weigh, so therefore I can't figure this out. Had I known what one of them weighs, I could have, but since I don't, I can't figure it out with just what he said. So in this situation, there are two unknowns, so we have to have two equations. All right, let's look at, what if I told you I was holding 20 coins? And some were a mix of dimes and quarters, okay? Could you tell me anything about how many of each I have? So if I tell you I have 20 coins and they're a mix of dimes and quarters, could you tell me how many of each I have? Well, you could not be specific. You could give me a list of possibilities. You could say, okay, well, you have 1 dime and 19 quarters, or 2 dimes and 18 quarters. You could give me a list, but you could not be specific. What other pieces of information would be useful in figuring this out? The total amount of money that I had. How many, did I have more dimes or more quarters? You know, things like that would be really helpful. All right, example number 1. Lulu tells her little brother, Jack, that she is holding 20 coins, all in which are dimes and quarters. They have a value of $4.10. She says she will give him the coins if he can tell her how many of each she is holding. Solve this problem for Jack. Okay, so I have two unknowns. I have the number of dimes and the number of quarters. So we're going to identify our variables first. So we're going to let D equal the number of dimes. And we're going to let Q equal the number of quarters. Okay, so there are two pieces of information here that I know. I know how many coins I have. I know I have a number of dimes and a number of quarters that equal 20. I also know the total amount that she has. So that's what I'm going to use to set up my two equations. So my first equation is, I know that I have a number of dimes, a number of quarters, and that is going to give me a total of 20. Okay? My second equation is going to be with the total amount that she has. So, I got to think about this. How do I figure out the total amount that she has? Well, I have to know how many dimes she has, and I know each dime is worth 10 cents. So, I'm going to say, okay, 10 cents D plus quarters are worth 25 cents, and that's going to give me a total of $4.10. All right? Now, I can figure out what D is equal to. All right? So D is equal to, if I subtract Q, I get negative Q plus 20. Now I can plug that into this equation down here. So 0.10 times negative Q plus 20 plus 2500 Q is equal to $4.10. Alright, now I'm going to solve this. So I get negative 0.10Q plus, well, 1/10 times 20 is 2, plus 2500 Q is equal to 4 10/100. Alright, combine my Q's together, and that gives me 1500 Q plus 2 is equal to 4 10/100. Subtract my 2. 1500 Q is equal to 2 and 10/100. Divide by 1500. And I get Q is equal to 14. Alright, so she has 14 quarters. Alright, now, I don't even have to go back and plug this in, because if she has a total of 20 coins and 14 of them are quarters, how many dimes does she have? She has 6 dimes. And there's her answer. Alright. Put that over there. Okay, let's look at our exploratory challenge. Okay, so at the state fair, there is a game where you throw a ball at a pyramid of cans. If you knock over all the cans, you win a prize. The cost is 3 throws for $1, but you have to have an armband. But if you have an armband, you get 6 throws for $1. The armband costs $10. Alright, so it says write 2 cost equations for the game in terms of the number of throws purchased. One without an armband and one with an armband. Alright, so we want to find the total cost. So we're going to let X equal the number of throws. And we're going to let C equal our total cost. Alright, now it said to write one without an armband. So let's think about this for just a second. So without an armband, okay, all they have to do is pay, it's 3 throws for $1. Now, here, I need to figure out what it would cost for 1 throw. So if it's 3 throws for $1, then I know that 1 throw will cost 1/3 of that. So C is equal to 1/3 X. Alright? Because it is 1/3 of $1, and it makes sense to leave it as a fraction because we can't find 1/3 of $1 actually. It's like 0.33333333. So we're going to leave it as 1/3 of that $1. Alright, now with the armband, let's talk about what that means. Okay, so my total cost would be, now in this case I get 6 throws for $1. So that means 1 throw would be 1/6 of $1. But I also have to buy the armband. So I also have to add that $10. Okay? So, these are my 2 equations. Alright, now, the second thing they want us to do is graph the 2 equations. So we're going to come down here, and I'm going to tell you that graphing this, we are going to kind of, our scale is going to be a little different. Alright, so I'm actually going to put a break here. Alright, and then I'm going to start counting like 11. Alright, so we'll go 11, 12, 13, 14, 15, 16, 17, 19, 21, 23, 25, 27, okay? And then I'm going to count by sixes here. And, well, I'm going to count by threes, actually. The reason being is because I get 3 throws for $1. Or I can get 6 throws for $1. So I'm going to start here, and we're going to do 6. And I'm doing every other one. Had a brain block there for a minute. Forgot what my next number was. Let's see, that'd be what? 7, 8, 9 would be 54 and 60. Okay? Alright, so let's look at this. This is our number of throws. And this is our total cost. Alright, so let's graph our first. Our first one starts at 0, 0. Alright, and I go up 1 over 3. Alright, so I'm going to start well, I'll tell you what, let's start with armband. I know that 6 throws are $10, right? Okay, so, I'm sorry, 6 throws are $1, plus that $10 would be $11. This will be the easiest way for us to do this. Alright, so then 12 throws, that would be $2, plus $10 would be $12. 18 throws would be $13. 24 throws would be $14. And you can see what's happening here. Alright? Okay, so that's with the armband. Without the armband, I'm going to come over here and say, okay, so without the armband, I know that it is 3 throws for $1. So 6 throws would be $2. 12 throws would be, so I need to kind of figure out where I can start my graph, because I am looking at some smaller numbers that I don't have on my graph. Alright, so I can go to 30 throws. So that would be $10. Alright, so 30 throws would be $10. And then I can move up from there. Alright, so this is what you're going to see. My graph is going to look like this. So this is without the armband. So they want to know, does it make sense for you to buy the armband? Well, look what's happening here. Without the armband, it's going to cost me a lot less. Unless I get to 60 throws, which is where we start to cross here. The only way it's going to be cheaper for me to buy the armband is if I'm going to throw this ball 60 times or more. Because with the armband, I'm going to pay more than I am without the armband. So does it make sense to buy the armband? Only if you are going to do 60 or more throws. If you're planning on doing 60 or more throws, then it would make sense to buy that armband because you're going to end up spending less money. But if you're not going to throw that ball 60 times or more, then you're going to save money by not buying the armband. Alright? Alright. So let's look at this. A clothing manufacturer has 1,000 yards of cotton to make shirts and pajamas. A shirt requires 1 yard of fabric, and a pair of pajamas requires 2 yards of fabric. It takes 2 hours to make a shirt and 3 hours to make pajamas. And there are 1,600 hours available to make clothing. Alright, so what are the variables that we are looking at? Well, we're looking at the number of shirts made and the number of pajamas made. Now, let's talk about this next thing. It says, what are the constraints? Constraints are things that cause us problems. And not necessarily problems, but it's things that, that could end up causing us problems if we don't think about and put into play when we are looking at this. So, one of those constraints would be the fact that they only have 1,000 yards of material. Alright? So a constraint is the amount of material, or how much material is available. I can continue making pajamas and shirts as long as I have that material. But when I run out of material, I can't make any more. The other constraint that I have is the number of hours they have available to work. So the amount of time the manufacturer has. Okay, those are my constraints. Now, because those are constraints, we are not going to be dealing with an equation here. We're going to be dealing with an inequality. All right, so write inequalities for those constraints. Well, let's look at this. I know I have to identify my variables. So we'll let x equal the number of shirts, and y equal the number of pajamas. Okay, now let's think about this. Can I make a negative number of shirts? I cannot. So I know x has to be greater than or equal to 0. Can I make a negative number of pajamas? I cannot. So I know that y has to be greater than or equal to 0. Now let's look at our constraints. Alright, so how much material? Let's deal with the material first. It takes 1 yard of material to make a shirt. So x plus, it takes 2 yards of fabric to make pajamas. So 2y. And there's only 1,000 yards of material. So it has to be less than or equal to 1,000. Alright? So 1 yard of fabric for the shirt, 2 yards of fabric per pair of pajamas, and that has to be less than or equal to 1,000 because I only have 1,000 yards of fabric. Let's look at the time it takes to make these. So it takes 2 hours to make a shirt, so 2x, and it takes 3 hours to make a pair of pajamas, and there are only 1,600 hours available. So that has to be less than or equal to 1,600. Okay? Now it says graph it. This is where those coloring pencils will come in handy. Alright, so let's look at that. So I'm going to graph. I know that x has to be greater than or equal to 0, so that means it has to be up here. And that y has to be greater than or equal to 0, so it has to be in here. So I'm not going to shade that part because that part is telling me it's got to be in this part of the graph. Okay, so then let's look at what we're going to do here. I'm going to count by hundreds just because, you know, that would make sense. So I'm going to skip every other one. And this is just to give my graph a little room to breathe and to make a little bit more sense for me. Alright, I'm going to do the same thing going up. So now let's graph it. So, if I were to look at this, if I were to actually like solve these and graph these, then let's go x plus 2y is less than or equal to 1,000. Alright, so I'm going to subtract my x. So I get 2y is less than or equal to negative x plus 1,000. If I divide everything by 2, I get y is less than or equal to negative 1/2 x plus 500. Alright, which tells me that my y-intercept is 500. And then my slope is negative 1/2. So for every, I go up 1 over 2. Alright? So if I go up 100, I go over 200. So I can go up, but it's a negative. So I would go to the left. I can't do that, so I'm going to go down and over 2. Down and over 2. Down and over 2. Down and over 2. Now, solid line or dotted line, it is less than or equal to, so it's a solid line. But remember, I cannot go into the negatives, so it's going to go from axis to axis. Alright, so my line stops there. Now let's talk about where I shade them. I am going to shade it down because that means that everything here is what I can make. Alright? I cannot make anything above this line. Alright, so I'm going to shade that. Alright, now let's go ahead and do our other equation. So I get 2x plus 3y is less than or equal to 1,600. Subtract your 2x, and I get 3y is less than or equal to negative 2x plus 1,600. Alright, divide by 3, I get y is less than or equal to negative 2x over 3 plus 1,600 divided by 3. Okay, now, 1600 divided by 3 is right around 533. It's not an exact number. All right, so we're going to do this about right here. All right, and then we're going to go down 200 and over 300. All right. Down 200 over 300. Mine's not going to be exactly right, guys, because, like I said, we've got that, we don't have an exact number. All right, it is a solid line. And then that would be everything here. So it says, what does the shaded region represent? Okay, so where both of them are shaded, which would be this area right here. Where both of these are shaded, what does that represent? Well, that represents the various combinations of shirts and pajamas that can be made. Okay? So everything here in this area is the combination of shirts and pajamas that can be made. So I could make 100 shirts and 100 pajamas. I could make 200 shirts and 300 pajamas, as long as it is within that area. Okay, as long as it is within that area. So it says, suppose that the manufacturer wants a profit of $10 on shirts and $18 on pajamas. How could you decide how many of each to make? Well, he wants to make as much money as possible. All right? He wants to make as much money as possible. That's kind of the whole point. So the maximum would be at one of the endpoints. Of the shaded region. Okay? The maximum amount of money they would make would be at one of these endpoints. Okay? So it wants to know how many should the manufacturer make, assuming that he will sell all the shirts and pajamas he makes. Okay, so if it's $10 a shirt, and it is $18 on pajamas, that's going to give us how much profit he's going to make. Here's what I would do. I would just choose some points. All right, so we can do 0, 500. We can do 200, 400. And we can do 800, 0. Okay? So those are just 3 points that I've pulled out of the shaded area. Alright? So let's see what that would cost, or what we would get here. So if he made 0 on shirts, and then 18 times 500 is 9,000, he would make a profit of $9,000. Okay? 200 times 10 is 2,000, and 400 times 18 is 7,200. So he would make a total of $9,200. And then 800 per shirt would be $8,000. And if 0 on pajamas, that would only give them a profit of $8,000. So he should make, just in what we found so far, he should make 200 shirts and 400 pajamas. Okay? And just in what we found, because that means he would have the most profit. Alright guys, hope you have a great rest of the week and talk to you soon.